Uh, hey, I'm Arthur. I am an information security engineer and the team lead for web security at Google. I've been at Google for a fairly long time, 12, 13 years now. And I like the web. To me, it's a very interesting ecosystem, and I'm trying to help make it a little bit better. I have to say I'm a little bit self-conscious because my talk is different in kind than the talks we've had in the workshop so far. To the extent that I think a lot of the focus that we've had in the SBOM presentations yesterday and the talks today were about protecting yourself or your application from things that you legitimately want to load, third-party components that you compiled in or load at runtime and try to limit their capabilities or at least surface them so that you can fix them in some way if need be. This is a problem that I will not publicly claim that this is a problem that Google doesn't have, because obviously we do have similar concerns, but because of the scale and resources, I think it's been a little bit easier for us to grapple with this problem. But what we do have, and the concerns that we see across our ecosystem, is tens, if not hundreds of thousands of developers writing code. And whenever you write code on a foundation that makes it easy to introduce vulnerabilities, you are going to have a lot of vulnerabilities. So in a way, I see the Google ecosystem as a bit of a microcosm of the broader web, of course, with the recognition that we do have more resources for security and engineering best practices and whatnot. But I was hoping to talk a little bit about whether what we have learned in our work to secure the thousands of applications at Google to help figure out better defaults and better built-in models for certain core aspects of the web platform. So I will get to cookies at some point in the next 15 minutes, but I did want to start with a bit of a broader view, just because I know we are all geeks and we are interested in cookies, but at some point it's also useful to talk about the underlying problem that we're solving. So the first thing that I asked myself when I saw this workshop proposal and I started thinking about my talk is the general idea of how do you secure something for the long term. Right? And the one approach that we have to pursue, no matter what we do, is to improve security processes, build additional security features. We talked about CSP. We need to have opt-in mechanisms that allow developers to extend additional security guarantees to their code. We have to get better at educating developers, detecting vulnerabilities, patching vulnerabilities. All of that is necessary for the ecosystem. But if there's anything that's better than making progress on this, it's to eliminate the vulnerabilities in the first place, right? If we can engineer our ecosystem or the underlying platform in a way that will not make it vulnerable to certain classes of problems, then we will not have to deal with all these other things, right? We don't have to teach developers about doing things properly because, at least for that particular problem, it will not exist, right? So developers will not have to learn about how to avoid it. And there are good examples of this in technology, right, outside of the web. For example, if you build things using a language that is not memory safe, then you're going to have memory corruption vulnerabilities. But if you build in a memory safe language that consistently enforces memory safety, then you will be free from this entire class of bugs that we've built huge ecosystems to detect and fix, like fuzzing and mitigations and all of that, right? It's nice to not have this problem. And this also applies to other languages, like TypeScript, for example, makes it pretty much impossible to have prototype pollution bugs, which you can have in plain JavaScript. And similarly, if you use Go, you're going to have less concurrency problems than if you have in other languages, just because of the language design. And this also applies to things that are kind of more specific than languages. For example, at the framework level, you can have ways to query the database that will make it impossible to have SQL injection. And there's many other examples of this. So the question is, how does that translate to the web, right? If we focus on improving the security of the web ecosystem in the long term, can we apply similar principles to improve the defaults to the kind of guts of the platform? And of course, this is challenging because the web has not been designed as an application platform. We are very worried about backwards incompatibility. We don't want to break sites that have been on the web for the past 20 years or even longer, and do things in the platform that will just prevent users who have been accessing these sites for a long time from being able to use them, right? So we're very averse to breakages. But we've also, over the years, been able to pull off a lot of backwards incompatible changes in the name of security. So for example, right now browsers are very vocal about discouraging HTTP and unencrypted transports. We've gotten rid of Flash, which made some users unhappy, right? There was a lot of great content on the web built in Flash, but the dangers that it posed to the web platform were arguably worth that pain. And there's also a lot of smaller deprecations happening in browsers all the time to improve the defaults, to remove some of the foot guns that otherwise developers would come across and make their applications vulnerable to certain kinds of bugs. And the idea for what I'll talk about in my talk is to understand which of these, the facets of the web, make it likely for developers to introduce vulnerabilities and figure out whether we can fix them. And of course, just to give a bit of a spoiler, cookies are one of the things that we would like to change the behavior of to improve the platform. So if you look at the data from, this is fairly old data, which I know is not great, but just kind of to illustrate the principle. A few years ago, we looked at I think it was thousands of vulnerabilities that we received via our vulnerability reward program. And there were obviously many vulnerabilities that were not web platform bugs. Those were web application bugs often. So servers being vulnerable to logic issues, mobile apps, and so on. But a large chunk of the security problems in the Google ecosystem was caused by the unsafety of the web platform. And that led to XSS and also a lot of what I would call isolation vulnerabilities like cross-site request forgery and clickjacking. So to dig maybe more deeply into those, I will make a bold claim that the bulk of web client-side security vulnerabilities fall into these two categories. So one is injections, right? There are, we all know it by the name of XSS. There's different kinds of XSS, DOM-based, reflected. You can slice and dice the problem class in many ways, but this is in the end, if you have an injection, it often means that someone else will be able to execute JavaScript in the code of your application and access all of the data within your origin, because as we learned from previous talks, the same origin policy is kind of underpinning most of web security. But I will not talk about that. I will talk about the other class of vulnerabilities, which is arguably more diverse, but just as interesting. And that is the area of isolation bypasses. And just to try to maybe talk a little bit about the root cause of these bugs, the problem that we have on the web is that there are many things that you can do in your application that seem very simple and legitimate and safe, but end up being security vulnerabilities unless you are, as a developer, are aware of the fact that you have to do something special to protect your application. So for example, if you have a form, or if you have a button that triggers some state-changing functionality, or if you have, in the third example, a JavaScript response that includes some user data, or even functionality as simple as searching the user's data, all of them are by default vulnerabilities in your application unless you figure out how to protect your application. So for example, if you have a form but do not protect it from a cross-site request forgery by using a CSRF token or the double submit cookie or one of these other core methods of preventing a cross-site request forgery, someone else will be able to submit that form and trigger that state changing functionality on in your application. Same thing with clickable UI elements. You can iframe them from an untrusted site by default, and the user will think they're clicking on a kitten, but they're actually clicking on a button to delete their account in your bank, for example. And these other two patterns are similar. And the root cause, arguably the root cause for all these vulnerability classes is the cookie model of the web. And this is the fact that cookies are obviously sent in first-party context, right? If you have a same site or same origin resource, it will be loaded with your cookies. But they're also sent in cross-site third-party context. So the browser attaches the cookie kind of in the default web model, right? Without the anti-tracking and other cross-site cookie protections, the browser will attach the cookie for the destination regardless of the source of the request. So obviously this is good for some things, but it also causes problems because it means that an evil website will be able to send requests with the user's cookies to a victim web server and confuse it in ways that will allow the attacker to attack the user and steal their data. So my argument for the next 7 minutes or so is that if we fix the cookie model, we will also protect the web from these broad classes of vulnerabilities. And luckily for us, from a security perspective, there is a privacy-focused effort by browser vendors over the past several years, started with Safari, then built by Firefox, now in the process of getting finally rolled out in Chrome, which is meant to protect users from cross-site tracking by deprecating or phasing out third-party cookies. And this is something that there is agreement across all browsers, various stages of implementation, but everyone agrees that we have to get rid of third-party cookies. And that gives us an opportunity to think about, since we're doing these changes for privacy reasons, can we also make these changes in a way that will improve the web's security model? And just as a quick overview, the way anti-tracking has traditionally worked, the kind of simplest mode of anti-tracking is if you have a third-party component, like an iframe, or if you load a third-party image from that is cross-site, originally in the web's cookie model, the cookie would get attached, but anti-tracking prevents the cookie from being attached on the cross-site request. However, it does not prevent requests made to the top-level site that the user sees in their browser window. So if you have a third-party component like an ad or something else, it can still trigger cross-site requests with cookies and attack the embedding application. And of course, we need to make the web safe, even in the event of embedding third-party functionality, because that's the web security model, right? You have to be able to embed other widgets and sites and things, and make that not be a problem for your application. So the second model for anti-tracking is based on same-site lax cookies. And same-site lax cookies are more strict, which is confusing because there are same-site strict cookies as well, but whatever. Same-site lax cookies are attached on fewer requests than just in the anti-tracking cookie blocking model, because they also apply to requests sent by embedded widgets to the top-level site. So kind of to boil it down to the core question is, what do we want in the platform, right? What, from a security perspective, how should cookies behave in order to create a robust boundary in the platform that protects all web applications from cross-site request forgery and similar vulnerabilities? So first of all, cookies should not be sent on cross-site requests by default, either for sub-resource requests or for iframes. The second element is we should not have cookies on post requests, even if they're top-level navigations. And if we do this, we get both the anti-tracking and the security benefits of the cookie model. And of course, if you think about these properties, this is exactly what same-site lax cookies already provide. So the argument I'm trying to make is, oh, and by the way, before getting to that part. We also have to figure out a bunch of different details about how cookies work. There's a lot of divergence between browsers as to how cookies are attached and when they are sent and when they aren't. So we're trying to go through, trying to systematize it and make sure browsers align on the actual behaviors. I will maybe skip this slide. This is getting into the weeds of how the cookie models should actually work. I'm happy to get back to this, but I'll try to wrap up and just kind of finish with the big picture again. What we would like to do is have a cookie model in the platform that protects applications from cross-site request forgery and related bugs, which is based on same-site lax cookies with some tweaks for compatibility, which do not undermine the security properties of same-site lax cookies. And if we do this, my claim is that we will actually protect the web ecosystem, create a robust boundary, almost a guarantee for web applications that they're not, they can't do anything to make themselves vulnerable to these long-standing class of bugs. And the good thing is that all browsers are fairly close to that just by virtue of the anti-tracking work that they're doing. And I think, I know this is challenging. This breaking things on the web is hard. It is, browser vendors are very hesitant to break more than what they absolutely need to get the privacy anti-tracking guarantees that they're after. But if we do this, right, and if we also make this a security boundary, then we will really make life easier for developers in the future. And by removing these classes of bugs that have plagued web applications for a couple of decades. And my final, this call to action that I would have for our group here is, browser vendors hear a lot about breakages of the work that they're pursuing, right? So if they block third-party cookies and that breaks some sites or payment flows or anything else, they will have angry developers yelling at them saying, hey, your browser sucks because it broke my website and that website has been working properly for the last 15 years. They don't hear about the I guess, collateral damage of allowing these sources of insecurity to persist. So our job as the security community is to tell browser vendors about the fact that how much pain this lack of safety causes to developers and the ecosystem itself, to motivate them to work more in this area. And that is it. Sorry for running over.